In the previous video about this Altair 680 computer, we worked on getting around the bottleneck the Teletype causes us by using this CRT terminal as our console and this high-speed paper tape reader punch to replace the paper tape functions of the Teletype. We then used this AB switch to hook these two devices to the same serial port so that the computer and the software thinks it looks like a Teletype with all these devices on one serial port. And this ended up working quite well for us. We were able to load the editor assembler package, which normally takes about 35 minutes on a Teletype. We loaded that in under a minute, about 50 seconds, so about 40 times faster. So that's just a dramatic improvement. And then we were also able to load the assembler source files that we wanted to work on into the editor with that same 40-fold increase in speed. So this was just a great improvement. Now we ran into a bit of a roadblock when we tried to punch tapes. So we did have to patch the editor assembler a bit. What we did is patch it to put a delay after each character when we're punching to not overrun the punch, which can only keep up at about 50 characters per second. And then the other thing we found we needed some time after we initiated a punch command to flip this switch over to the punch and have it ready before it started sending data. So we put a 3-second delay in whenever this was about to punch. And with those minor patches in place, this ended up being a very workable system, just dramatically faster than using a Teletype. I mean, it's still inconvenient. You still have paper tape, but it was still dramatically better than paper tape. Than a Teletype. So what we're going to do in the video today is see if we can make this same thing work for Altair Basic for this computer, just like we did for the editor assembler. Now, if you haven't watched that previous video yet, I would recommend watching that first. It'll give you the background you need, and I'm also going to gloss over things in this video that I will just assume you've seen in that first video. To make it easy to find that, I've put a link to that video in the description field for this video. Here you can see a copy of Altair's Basic for the 680 on the left and the editor assembler we were running in the previous video over on the right. They're both about the same size. They load in the exact same manner. So as you'd expect, we can load this 8K basic tape with our high-speed reader in about 50 seconds, just like the editor assembler. So right off the bat, we'll get that 40-fold increase in speed, which is absolutely great. Now, unfortunately, that's where this advantage ends, because we're not going to be able to load programs into BASIC at that higher rate. And the reason is because BASIC needs quite a bit of time at the end of each line to process the line once the carriage return comes in to signal end of line. It needs about 300 to 400 milliseconds. And even with a Teletype, there needed to be delays put in so that the Teletype did not overrun the Altair. This includes the 8800 as well as the 680. And that was typically done by punching 2 or 3 nulls after each carriage return line feed to give time for that to occur. Those 2 or 3 nulls plus the line feed character were all basically don't cares that could be trashed and provided the delay you needed. Now on this high-speed reader though, that's coming in at 400 plus characters per second. We're going to need at least 150 nulls at the end of every single line. And that's just not going to be feasible, reasonable way to do this. So we're going to have to come up with something else. And unfortunately, short of programmatically starting and stopping the reader at the end of each line, which is just going to slow us down, and again is not what we're trying to accomplish here, we're going to have to try something totally different than coming through the BASIC console. And I think the answer to that is the cassette interface board that MIT's introduced for this board, for this Altair 680 computer. When they introduced the cassette board, they also created another version of BASIC called Cassette Basic, which is basically the exact same thing as what's on this paper tape, except they added the cload and csave commands to load and save from cassette. And those commands simply dump memory out to the cassette or read from the cassette straight into memory. No processing is done in terms of trying to interpret the data. So it can be very fast. I've done it at 9600 baud even over on the 8800. So I know this will be able to keep up with the paper tape. So basically what we want to do is modify the cload command to load from our paper tape through the console port and the csave command to go out to the paper tape through the console port instead of going through the serial port that's part of the cassette interface port. One good thing about this is that the cload and csave commands were added to Altair Basic. Basic itself hardly even changed, so these new commands will be fairly isolated, and it's a very simple loop to write that data from memory out through a UART to the cassette and read it in. So it shouldn't be hard to find, and it shouldn't be very large to patch. In essence, what we want to do is wherever it's referencing the serial port for the cassette, we're going to reference the console port to go to our paper tape or from our paper tape. And as before, during punching, we're going to have to put in a delay to slow it down so that it doesn't overrun the punch, about 49 characters per second, to keep it under the 50 rate that is advertised for the punch. And then also we're going to need that delay. When you type C save return, you're going to want to have a few seconds to flip that AB switch over to the punch before it starts punching. But it should be fairly simple to do, fairly simple to find. So I'm going to go ahead and load the editor assembler into this computer, and let's take a look at the first set of patches I did to try to make this work. I've loaded the editor assembler, and I've loaded the patch source file I've been working on. What we're looking at here first is actually the read loop that's in BASIC that I have patched right in place because it's the exact same length, with routines to read from our punch reader instead of from the cassette. I looked for F010, which is the address of the cassette UART, and replaced it with F1000, which is our console UART. And this loop is basically the exact same thing all in place. So that was easy to find by searching for that F010. Likewise, very close was the write routine. However, it doesn't quite fit. So I call the monitor to actually output the character, and then I jump into a patch area that we'll look at in just a second to do the delay we need, the 20.5 milliseconds to make it come out at 49 characters per second. The only other patch we needed was at the start of the C-save routine. I found that, and we jumped to delay 3 seconds to give the operator time to switch the switch to the punch before it starts actually punching after initiating that C-save command. Let's see, C24. All right, the actual punch code, I've stuck up at the top of the 16K RAM card for now, just to try it. Now, eventually I'm going to want to make it somehow load with BASIC. We'll look at that later. So just like before for the editor assembler, we have this pacing routine that does the delay of 20.5 milliseconds. And then down here at the bottom, let me advance a bit, we have the actual 3-second delay routine that gets called when you initiate a save operation. And that's it. So a very simple set of patches. So what we need to do is go ahead and assemble this. Let's go to the assembler. No. First pass. I don't know if I got that. First pass. And second pass with a listing. You can see our assembled code here. But what we need to do now is punch a tape, because that tape is what we're going to have to load to actually patch cassette BASIC when we load it. So to do that, I do a 2T. Let me step back a bit here. All right, so I hit return on the 2T, flip over to our punch. That's done. Back to the console. And you can see we're back to our enter pass. So this tape right here is what we're going to need to load in order to do to patch BASIC. Now, the process would be I load cassette BASIC into memory, and then I load this patch on top of it, and we should be good to go, being able to use the punch for C save and the reader for C load. However, I only currently have BASIC on cassette, because this is cassette BASIC after all. And I don't want to punch a tape yet because I want to make sure it all works before I waste all that paper tape. So I'm actually going to load it from cassette. Here you see I have the cassette interface board installed in my 680. And I just have cords coming out temporarily for now to hook into the playback on this tape. So here's our cassette tape. We'll put that in. All right, and then we'll come over here and we'll boot cassette BASIC into the system. Now, to boot cassette BASIC, we normally boot things by typing the L command. Well, unfortunately, the L command's not going to work because that wants to load through the console port, and we need to load through the cassette port. So when you purchased a cassette interface board, you also got an EEPROM. You put that EEPROM in an empty slot on the motherboard at FD100, and jumping to FD100 is the exact same thing as an L command, except it comes from the cassette instead of the console. So I'm going to reset this computer. Gonna jump to FD100, so that's a load command, and I'll hit play. All right, what this does now is load whatever it finds at the front of this tape in S-record format, and typically that is going to be BASIC, and it takes about 13 minutes to load BASIC in S-records. However, that's not what I have here. At the beginning of the tape, I have a small binary loader. It's going to be done here in just a few seconds. And when it does, I'm going to jump to it. It's at 3F100. Here we go. So I'll jump to 3F100. Now my binary loader is running. And that binary loader is then going to read the rest of the tape to load basic, except it'll get done in about 4.5 minutes instead of 13. The reason for that is because I have written cassette basic to tape in a binary format with some checksums every 256 bytes or so. I've actually just duplicated the format that MIT's used for the Altair 8800. It worked just like we described here, with a loader at the front of the tape, and then basic as a binary payload following that. And of course, you can load in 4.5 minutes instead of 13. That's great. So why didn't MITS do that with the Altair 680 software they distributed? Who knows? All I can think is, again, like I've mentioned in other videos, they did it to make sure this 680 stayed slower and less attractive than their 8800, even though it could have loaded in the exact same speed as the 8800. Now, I've gone over this process of making this two-stage loader with a binary payload in another video where I discussed the cassette interface and how to improve it. So I put a link to that video if you want to watch how I did that. It's in the description underneath for this video. Now, when I do punch this tape finally, I'm actually going to punch it in this same manner. We're going to have a little short tape that you load first. That's the binary loader, just like the front of this cassette. And then I'm going to feed a binary version of cassette basic, and it will have these patches already in it, because that will be about 1/3 the length of the full S record tape. This saves a lot of paper tape, also saves all the winding up that you have to do at the end. It won't really be any faster in the end because this paper tape reader is so much faster, but it is nice having a lot less tape. All right, so as we go on with this, you can see that this loader is giving us progress. Cassette basic is about 7,000 bytes long, which will get us up to 1C100, so we're at 0B. So we'll come back when this is almost done and finish up from there. All right, this is nearing the end. Now, another thing that the Altair binary format had was a jump record at the end. There we go. Automatically jumps into the program for you. So that's nice during normal operation. But in this one particular case, I don't really want to run the program yet because I still want to apply the patch. Let me stop the tape reader. Right, so I'm going to reset the machine. And we are now going to load those patches with the L command. Let me just go back real quick here so you can see it. So we'll switch to the reader, hit read. Patches are very small. All right, and now we should be able to jump to 0. All right, now I put this up at the top of memory in the top 256 bytes of the 16K, so I have to tell it it's got 16,000 bytes available. That'll save the top 384 for the patch that we just stuck in there. And also it keeps it from overriding it with a memory test there in the beginning. All right, terminal width, sine, cosine, sure. All right, we're up and running. This KCACR is the Kansas City audio cassette recorder format. So this is basically how it says it. It's cassette basic instead of the regular one. All right, so now let's run a little program. I'll do my usual one. And see what's backspace, I'm not sure. 30, next I, 40, print, done. All right, so that works. So now let's say you wanted to save this program. We're going to want to use the csave command to do that. And you give it a file name, we call it test. And that file name doesn't really matter other than the first character. All right, so this is where we have it set a 3-second delay for us when we hit return so that we can turn on, flip the switch to the punch. So I'll hit return. Within 3 seconds, turn that to punch. And there's our output. And let me go ahead and feed that at the end. So you see that's a very short program. I'm going to stick it in the reader over here so that we can read it back in. All right, so I'm going to go ahead and do a new here. If I do a list, you can see it's empty. Now I'll do a C load. give it the name test, and again, all you really needed is the T. So now I'll switch this to the reader, hit read, go back to basic, and hopefully our program's in here now. There it is. All right, so it works. We have got set basic patch, so the cload and save commands can use our paper tape punch, and that's actually quite a bit faster than the cassette is. Now all we have to do is create the tape that we want, so that we can load the tape from paper tape and not have to deal with cassette at all. So that's what we're going to do next. But I also don't like the fact that I have put this up in high RAM on a 16K card. What if somebody had 32K of RAM? What if you forgot to type that 16,000? Then you would end up clobbering the patch we put in. So what I'd really like to do is put this right at the end of basic and then protect it, kind of like we did with the assembler. But as I did that, I found it's a bit more complicated than with the assembler. So let's go ahead and do a video cut and bring that into the assembler and take a quick look at it. All right, so I've got the final version of the patch now loaded up into the editor assembler. What we're going to do is put our new patch code at the end of basics code. That stops at 1C18. We're going to load our stuff at 1C18, the new code we're adding. Now, what's interesting about basic is that is the end of all the initialization code where it says memory size, terminal width, want sign, cosine, etc. That all then gets thrown away after initialization is complete. And it frees up almost 512 bytes, which in the old days was quite a bit of RAM. So at the end of doing initialization, end of memory is down to 1A48 instead of up in the 1Cs. So what we're going to want to do is move our patch down to 1A48 after basic initialization is done. So it's going to load at 1C18, basic will do initialization, and then we'll copy our code down to 1A48 where it actually runs. So I've computed this value of offset, which is the difference between where it is when we assembled it and loaded it into RAM and where it ends up. All right, so let me forward just a little bit here. Well, you can take a look and you can see how this affects it. So this save X is loading at 1C18, but in reality, it's at 1A48. And so anywhere I'm absolutely referencing an address, I'll subtract the offset from it. Most of your things are relative, like branch not equals a relative branch. Let's see. Return subroutine, of course, doesn't matter. Here's our delay routine. It's completely relocatable. Nothing in it references anything absolute other than jumping back into basic, which is the same. All right, so this is the new patch code that has to be moved. So when basic finishes initializing, I'll show you this patch in a minute, it jumps to move path, which comes in here and it takes the, it's going to use the stack to do a move, so I don't have to keep switching X back and forth. It's going to move from the load location to the paste pun minus the offset to the destination location. So this moves it, and then it tells basic, here's your new end of memory address, which is just right there at the end of the patch. And that's it. And then let's see, somewhere in here is the all right, moving to the end. So here's the 3-second delay that we had before, and what's new is now in basic, where it was done with initialization, I've put in a jump subroutine to that move patch routine, which then completes the initialization and everything then runs. All right, so now what I'm going to do is go ahead and create, actually I've already done it, I'm going to create the loadable tape for basic, complete with the patches in place. And we're going to do it like we just showed, loading from cassette. And that's going to be where we have got a binary loader that we load first that's small, and then we turn around and load a binary version of the tape instead of the full S record version. If you take a look, you can see the difference in size here. Over on the right is the full S record version of basic as you'd get it from MITS. Over on the left is how big it is when you use the binary version that loads quicker. Now again, with this paper tape, the quickness isn't really going to make much difference because it's going to be handling the paper tape and inserting it twice. But it's nice having that tape smaller and less to pick up. So let me get that ready to load. All right, so I have the binary loader in the paper tape reader. That was the thing that's at the front of the cassette tape. And then the spool up there will have to load second. That is what was following on the cassette tape. So let me reset the machine. I'll do an L command over here on the monitor. set this to the paper tape and hit read. All right, so that's the binary loader is now in place. Come back here to the monitor and jump to the binary loader at 3F100. Put that tape in now. This is actually the basic tape in the binary encoded format that the loader's looking for. And hit read. All right, again, this loads quicker than the 50 seconds that the other one took, but by the time I did that first tape, switch the switches back and forth once or twice, you can see it's really no faster. But it's nice having a smaller tape, and there's less to clean up when I'm all done. All right, when this finishes loading, it's going to automatically jump to whatever it loaded. So I switch that back to A, and you'll see that it starts basic up there for us. So that's kind of a nice little feature. All right, and now I can hit return here and let it size memory. I think I've got a lot in here right now. Let's say yes. Yeah, I've got 50,000 free bytes. I have a modern day RAM card in here that gives me all the memory I need. All right, and so now we could load and save things. So let me do a demonstration real quick. I'll C-load our test program, if I can find it. Where did I leave that? I think this is it right here. Stick it in the reader. Switch this to B, hit read. Back to A. Oops, did something wrong. Try that one more time. Let me start off basic over again. All right, so C-load test. Switch to B, hit read. Back to the terminal. There's our program. All right, still not perfect. There's still little bumps in there. Not as easy as disk, of course, but that was a ways away still and cost a lot more, although these paper tape readers wouldn't have been cheap either. All right, but that does it. So we have now got basic working with paper tape, high-speed paper tape, quicker than cassette, much quicker than Teletype. And we can load and save programs. We can load basic quickly. And we've done it with the editor assembler well. So pretty nice setup in the end. The only thing I'd like to do different is not to have to use that AB switch all the time and go around these delays because of the AB switch. And to do that would be if we had another serial port that we could plug that reader into. And that's what we're going to look at in the next video, is one of the standard boards available for MITs for this 680 was called the UIO board. It has a serial port on it. We'll connect the paper tape reader punch to that serial board and do very similar routines to what we've done here. That'll let us use it just like a cassette where it doesn't affect the console at all. And then that will end this series about the paper tape reader and punch.